All right, everyone. Welcome to the very first Thunderbird and Rust Office Hours. I'm Brendan, and with Heather also on this call will be your hosts for this and all future editions of the Rust Office Hours. We both work on at MZLA, the subsidiary of the Mozilla Foundation that works on Thunderbirds, and where we do a fair amount of Rust in the projects we're involved in. These office hours will happen on the third Wednesday of the month every 2 months at 8 p.m. UTC. At least that's the plan that might change in the future, but that's the plan for now. They're open to anyone, both MZLA staff and not, and they will be recorded so that everyone has a chance to catch up. They will be mainly focused on Rust and how we use Rust within Thunderbird, and they're meant as a space for discussions around specific questions or issues that people might have around in the context of using Rust for Thunderbirds, but also some presentations on specific topics in that area. This time we're going to be looking at the Thunderbird code base. We're gonna focus a bit more on the presentation this time. There will be a time for discussion afterwards, but for now we'll focus on the kind of presentation, giving an intro to the Thunderbird code base, which might be a bit less interesting to seasoned Thunderbird developers, but we'll also spend quite some time looking at the state of the Rust integration. I think at least half of my slides are about that, so there will still be something interesting if you're already familiar with Thunderbird code base. And speaking of which, let's kick things off. So for anyone who's not familiar with hacking Thunderbirds, writing code for Thunderbirds, the Thunderbird code lives in a Mercurial repository. There is a plan to move to Git at some point in the future. We don't know when yet. For now, it's on Mercurial. It's indexed on Searchfox because the web Mercurial interface isn't as glossy or easy to use as something like GitHub or GitLab to actually look at code and share code snippets. So we use a tool called Searchfox, which is the same that Firefox developers use to work on Firefox and adjacent projects. Thunderbird is built on top of Firefox. Kind of dates back to the days of the Mozilla suites, where Thunderbird and Firefox were essentially the same product. They're separated, but they still share a lot of code in common. Typically, and you can see that on our developer documentations, if you want to build Thunderbird, you'll first check out Firefox and then Thunderbird as a subdirectory of that. When we talk about Thunderbird codes, we'll usually make a kind of front-end, back-end separation. That separation isn't as clear-cut as we'd ideally like, at least not yet. We're working towards it. And you've probably heard, if you're not familiar already with Thunderbird, you've probably already heard the terms backend and front-end in other applications that you might have been involved in. The difference in Thunderbird is the backend code doesn't live on some kind of server on the cloud. Both the front-end and the backend are part of the client application that runs on your computer. We call the front end everything that is UI related, that has some processing logic in order to, with the final goal being to display information to the user. Most of that code for mail, I'm kind of focusing on mail right now, even though chat calendar and address book follow roughly the same guiding principles, but for now it's easier to focus on mail. And so most of the front end right now lives in the mail directory of the Thunderbird repo. The backend is mostly around the logic that is not directly user facing. So for example, on disk storage management, protocol implementation, integration in the user's operating system, so on and so forth. Most of the backend code lives in the mail news directory of the Thunderbird repository. And the backend is also where we use Rust, at least for now. We want at some point to start looking into maybe integrating some bits of Rust into the front end, maybe with a project called Unify that the Firefox developers are working on. that's kind of TBD to figure out exactly how we want to approach that. The Thunderbird code is written in three different programming languages. That code is split between some JavaScript, some C++, and some Rust as of about coming on a couple of years ago. And those three programming languages interact over something called XPCom. XPCom stands for the cross-platform component object model. It is something that is entirely specific to Mozilla code, well, more specifically Thunderbird and Firefox code. And the idea is to describe different components, well, the shape and object model of some components via interfaces defining what's called XPIDL files. One example here is an interface called NSI URI, which is how a URI is represented within the Mozilla code. So for reference, this is what Searchfox looks like. And so you can see that with an NSI URI interface is defined here with, a spec, scheme, maybe username and password, maybe surely a host, maybe a port, the standard stuff you would usually expect to find in a URL. XP then uses those interfaces to generate bindings for C++ and Rust at build time. And from there, those components those interfaces can be implemented by declaring, can be implemented in various languages, and those implementations can be in manifests. You might see a bunch of files around the code base called components.conf, and that is essentially what they will contain. Each component is identified by a contract ID, and then other code can then use that contract ID to instantiate a specific component via either create instance for kind of normal instantiation, or get service for single to nice services. I've also specified here the various function names because they differ between C++, JavaScript, and Rust in that order. That's in the order then on the slide. And so that is XPCom is what we use to be able to enable the integration of Rust within Thunderbird code. Support for Thunderbird code for Rust, in Thunderbird code was added towards the end of 2023. Unlike the rest of the backend code, it lives in the Rust directory of ComCentral, which is the Thunderbird repository on Mercurial. That Rust directory is a cargo workspace that replaces Firefox, replaces the workspace that Firefox uses and kind of it acts as a kind of superset of that. There were some complications that we might get into in a future edition of the Thunderbird and Rust Office Hours around having our workspace being nested under Firefox's, so it was easier and more maintainable to just replace it. That workspace is centered around an internal crate called GK Rust. And that crate essentially is the one exposing all the symbols that can be then used by the rest of the Thunderbird code to kind of interact with all the Rust code that's in there. There is some automation to keep the dependencies in sync between our workspace and the workspace of Firefox. And again, we'll probably get into that in a future edition. And in general, we follow Firefox's MSRV policy, so minimum supported Rust version policy, which at the time of recording was recently updated to Rust 182. In terms of how we use Rust within that workspace, at the moment we use a lot of XPCom to both write XPCom components in Rust, but also reuse some components that were that have been already written in other languages. Firefox thankfully provides a crate called XPCom, which is internal to the Firefox code base, but we inherit from it in Thunderbird. It provides some helpers to access the shape of XPCom interfaces via the XPCom interfaces module, but also helpers to instantiate XPCom components with the create instance function, and also a bunch of macros to write your own components in Rust. The error handling management of XP doesn't necessarily match very well the idiomatic error management of Rust. By default, all XPCom methods are generated to return something called an NS result. NS result is a type which is essentially just an enum with a lot of different result codes. Some of them are successes, some of them are failures, and some of them are kind of more precise than others. You can see on the right-hand side of the example here. I'll get to that example, to the whole example a bit later on, but NSOK, for example, is one variant in the NS results enum. All those all the variants of NS result are provided by the internal NSRR crates, so we can access and process them in Rust as well as we would in other languages. And the XPCom crate also provides a helpful macro to turn kind of an idiomatic Rust function into one that matches the expectations of XPCom. So for example, in that example, something that XPCom would expect would be something like you have on the right, which is unsafe, because all of the bindings are by nature unsafe. They use a lot of pointers, and they have to return an NS result. XPCom methods macro on the left allows to establish a mapping between a function or a method written in more idiomatic Rust and its equivalent XPCom methods. So for example, here, the onStartRequest function with snake case returns a result, uses a reference, is safe, and with the XPCom methods macro, we can essentially tell XPCom to do kind of the translation. In the background, it essentially kind of creates an onStartRequest in Pascal case that looks sort of like this, but that way it abstracts a lot of kind of nitty-gritty, less idiomatic aspects of using XPCom in Rust. The NSRR crate that provides NS result also provides a bunch of helpful helpers in addition to all the known status codes that I was mentioning before. It also provides methods on NS result which are failed and succeeded, that allows to easily figure out whether a result is a failure or a success without having to compare against the entire possible result codes. It also provides a to_result method that turns an NS result into a Rust result and allows more idiomatic error propagation with the question mark keyword like you would find in most Rust codes. Another specificity of native code in Thunderbird and Firefox are the string types, because of the context in which that code runs. There's a variety of string types that are defined within the Firefox code base. They're all described in the string guides linked here. I will share the slides on the Thunderbird developers mailing list after this. And some of those string types are designed to be, for example, easier to use between the JavaScript to C++ boundary, because both languages don't use the same encoding as the other, or Rust and C++ don't use the same string termination methods, and so those types are meant to kind of standardize the way to deal with strings across the entire code base. And those strings are also designed to work, well, by extension, across the XPCom boundary. There's an internal crate called NSString that is provided by Firefox, and also one we inherit from them, which, if you're already familiar with the string types that we use in C++, so NSAC string, NSC string, we use the same string types in Rust. Whenever we can, we use kind of Rust the string types that are native to Rust. But whenever we need to interact over XPCom, those are the types we use. If you're not familiar with those with those string types, they're usually, each kind of category of type will have a concrete type and an abstract type. For example, in the example here, NSAC string is an abstract type, which we can see because of at the start of the name. NSC string is the concrete version of that type. A lot of the XP bindings will expect that the abstract version of a string type is passed to the consumers or to method calls, but usually you'll be dealing with a concrete type. And so to help with that translation, all of the concrete string types implement the deref trait towards the abstract type. So for example, NSC string implements the deref trait with NSAC string as its target. So now that we have kind of those basics, let's have a look at what writing and exposing a new component actually looks like in Thunderbird's Rust code. So first, I'll assume that you'll have already an XPIDL interface already written, whether that's one that already exists or one that was written specifically for the occasion, although we try to limit that latter case whenever possible. The XPCom and XPCom method macros are very helpful in declaring and implementing the implementation of an XPIDL interface in Rust. The XPCom macro, so XPCom : XPCom, will usually be as a kind of attribute of a struct that is the struct that implements that interface, and will have an implements argument with the specific name of the interface it implements, and then XPCom_method can be used to facilitate the implementation of each specific method of that interface on that struct. The next step is to write a quote-unquote constructor, even though that's not really a concept that exists in Rust. In this context, a constructor is a public function that will receive some XPCom specific arguments, always the same. There's a link in the slides to our Rust documentations with examples for that. And the only role of that function will be to create an instance of your structure. That constructor needs to be an unsafe extend C function, because the next step is to expose the symbol for that function within a C header file in order to be kind of linkable and usable by the build system and other parts of the code. Then, as I mentioned, every XPCom component needs to be added to a components.conf manifest. And so that's kind of the next step. It's just a few lines to essentially indicate the contract ID of that new component, which interface it implements, and what function to use to instantiate it. And then if we're creating a new crate, we also want to expose it in our GK Rust crate, which again is the crate that we link against when building Thunderbird. So essentially that allows the linker to find all the right symbols and all the right code to link against. And that last part is as simple as just adding an extern crate line in GK Rust. When we want to use existing components, that's a tiny bit simpler. We can, as I mentioned before, instantiate it with functions that are provided by the XPCom crate. So crate instance or get service, depending on the nature of the component that you need. Bear in mind that calling a method of an XPCom component is always unsafe. The XPCom boundary at the moment is always unsafe. There are discussions going on fairly slowly, but still kind of happening about improving the state of the current bindings to potentially make that boundary a bit safer and removing the need for unsafe code everywhere. But we're not there yet. In terms of safety, because there is still some amount of safety to ensure memory safety across that boundary. We have a type called a refptr for ref counted pointer, which is a smart pointer provided by the XPCom crate, and as well as a helper, which is getter address, to turn a mutable row pointer into a refptr. So you can see an example here where we are using get service with the right interface. Most interfaces will start either by NSI or just I to indicate that name is for an interface. We'll then give it the contract ID for the specific component that we want to retrieve. That get service returns an option, so we need to ensure that we do get something out of it, and our instance will already be within a ref pointer. When we want to retrieve something from a function call, because most XPCom methods will again return an NS result, the actual return values are retrieved via output parameters. And so we can use a getter address to essentially retrieve the value that we want as a mutable row pointer, and then turn that into a result which value is our instance within the refptr. And so that function already does call the toResult method of NSResult that I mentioned before. This is why we can just propagate the error immediately. In terms of documentation, a lot of what I've just explained is documented in the Thunderbird source docs. There's a link just here. There's a lot of kind of documentation within the internal crates, but unfortunately that documentation doesn't live anywhere on the internet right now. I know that the Firefox developers are talking about trying to find somewhere to host it, but it's not there yet. In the meantime, you can just run cargo doc in any crate within the workspace as you usually would, and that would output some HTML at the expected location, which is the target/doc directory within the Rust directory of ComCentral. And that is very helpful to document some internal dependencies such as XPCom and for instance, generating the documentation for the XPCom crate also generates the documentation for the interfaces module of that crate, which is a good way to easily see how each method of an interface has been kind of transported into Rust, how it's meant to be used, how the kind of specific type translations work. We also have some some crates that are developed externally from Thunderbirds that we host on GitHub, on github.com/Thunderbirds. The reason we write some of our Rust code outside of the Com Central repository is to try to maximize interoperability. For example, one of our big project at the moment is supporting Exchange in Thunderbird, and a fair amount of the code to support that project is written in Rust. And some of it is written in an external crate on GitHub with the aim to then be able to potentially port that code into the Thunderbird for Android app, probably iOS as well when it exists, and also open the door for potentially other clients to reuse that work. The kind of separation between internal and external is when whatever depends on external crates on internal crate from Thunderbird or Firefox lives within the Com Central repo. Everything that doesn't strictly depend on it lives outside of it, and in the future will also work towards kind of implementing that even further and trying to move as much Rust code as we can to those external crates. In terms of the future of Rust within Thunderbirds, first I have to say I'm sorry. The plan at the moment is not to rewrite the entire Thunderbird in Rust. We will likely end up rewriting some parts of the code in Rust as we modernize it and we consider what language is better fit for that rewrite. Another thing we want to, but something we do want to kind of improve on is to move a bit further from our dependency on XP and closer to something more standard like FFI. XPCom will still be needed in some cases because at the moment there isn't really a good kind of standard solution for transposing an object model between C++ and JavaScript and C++ and Rust and back. And so for now, we will be using XPCom for that. We might explore other solutions, like I believe CXX might allow some transition of the sort, but that's kind of a question for the future. And as I mentioned at the start, we'll also want to explore at some point better interop between Rust and JavaScript using FFI and working closely with the Unify team within Mozilla. As I mentioned, a lot of what I've just talked about is, with more examples, is described in the source docs on sourcedocs.thunderbird.net. There's a whole Rust section that you can take a look at. We also have a room on Matrix dedicated to the oxidization of Thunderbird, so the use of Rust in Thunderbird. We also have our kind of more classic Thunderbird developers channels on Matrix and on the mailing list. And the mailing list will be where I will share the slides for this presentation. And speaking of presentations, the next topics on the list, if you're interested for the next editions, will have an overview of kind of a more concrete example of how we use Rust in Thunderbird by looking at the Exchange code. So as in the code that we use to implement Microsoft Exchange. We'll also do a deep dive into the automation around Rust, that we have around Rust to make it work better in Thunderbird, and also to integrate it into our build system. We'll do a walkthrough with a tiny bit of live coding, probably on how we write new EWS features to get a bit more of a hands-on example. And also on the list is taking a look at how we use Rust to power the Linux system tray and provides better OS integration for all Linux users. And if you want to add a topic to the list, it's definitely not a closed list of ideas. Feel free to ping me via email or Matrix if there's something specific that you would like to see discussed. And on this note, this is the end of the presentation. And If anyone has any question or things they would like to discuss, the floor is yours. Yeah, Heather.
Hey, okay, there we go. Yeah, so thank you very much for walking us through this very important foundational concept leading up to these next topics. I have a couple of questions. One of them was at the beginning, you mentioned that the code base is JavaScript, C++, and Rust. What if down the road there's some new language that we want to integrate? How difficult would that be? Yeah, how difficult would that be? Would that just depend on like XPCom's bindings with that language or?
It will probably have to be decided on a case by case basis. I think the first thing to consider is we don't necessarily want the Thunderbird's code base to become a place where you need to know 10 different programming languages to be able to contribute. So there will probably be a limit of number to some extent. Also, one of the things that facilitated the integration of Rust within Thunderbird is that Firefox already uses Rust and has been using Rust for a while. And so the Firefox build system that we kind of inherit from also already supported Rust, which meant that we still had to do some modifications to it that we upstreamed to Firefox, but we had kind of a lot of that work kind of cut out for us. So that was one of the things that made that integration a bit easier than it would be with other programming languages. I think those kind of the two, and also the fact that, again, also because Firefox has been using Rust, there was already some infrastructure existing in the build system and in the XPCom code to generate some some XPCom bindings for Rust, and that's also something that made integrating Rust easier. I'm not saying that if there's a very cool language that we would hugely benefit from, and we think about it thoroughly and we decide it would be a good addition. Doesn't mean that if it doesn't have those two things, we would bail on it, but those are kind of important points to consider and probably the main friction points to adding something new.
Yeah, cool. It's good to know that we are not eager to add more languages to, make sure that the barrier stays low and
Yeah.
maintainability stays high.
Yeah.
Alessandra has a good couple of questions. Do you want to unmute and ask them, Alessandra?
Sure. Yes, I can do that. Thank you so much, Brendan. Awesome presentation, very thorough and great overview. I
Thank
was
you.
wondering from your team's perspective, as our code, Rust code specifically, lives currently both in the Thunderbird main repository, but also there's a little bit of a mirror, or sometimes there's an exploration that happens in the GitHub repository where we have some crates that they leave there. Where do our contributors should primarily look at, submit patches, open issues? What is the preferred path to you?
Yeah, that's a good question. We monitor both GitHub and Bugzilla. I think ideally Bugzilla is a good kind of central place for us to track everything that is kind of related to our code, and that way we can more easily duplicate reports or feature requests. So I would say Bugzilla, but also if you want to contribute to Thunderbird, whether that's by submitting a bug report or requesting a feature or submitting a patch, and you see a place that looks like the right place, don't feel too pressured into finding the one exact place. If we're monitoring, as I said, both GitHub and Bugzilla. If you open in the wrong one, we'll just transfer it into the right one and kind of work with you into kind of solving any of those issues or implementing that missing feature with, regardless of where it starts. And if you're not sure and you really don't want to get it wrong, the developer channels, both on Matrix and in the mailing list, are always good places to start the discussion.
And I would just like to add that you can always, I think, ping either one of us to, and just kind of say, hey, I want to do this thing. I want to accomplish this goal to, add to the Rust code base. And we can try and guide where that pull request or patch would go.
Yeah, absolutely.
Toby also has questions. Toby, do you want to unmute and ask them?
Oh, yeah. I was wondering for a new contributor, whether there might be a set of patches or a simple feature that's been added that someone could follow to see how the various pieces fit together. And kind of a follow-up question, if someone was only comfortable, let's say in Rust, do you accept contributions just in Rust? Like, could someone work on EWS RS and not get tied up in the C++ world? Like, are there ways that you would accept work and kind of help someone with the other pieces, I suppose is what I'm trying to say.
Yeah, absolutely. So before I answer, just for context for the listeners, so EWS RS is one of those external crates that I mentioned, which has types and a tiny bit of logic that we use for supporting Microsoft Exchange in Thunderbird. In terms of a set of patches to kind of refer to, there isn't really a good one that comes to me right now. Things are kind of a bit in flux, so what might be ideal now might not be ideal in 6 months. So I'll give that another thing, but for now there's not really an ideal answer. In terms of whether we accept Rust only contribution or whether we expect a contribution to go like kind of the whole way also into C++, because a lot of our, in the case of Exchange, for example, a lot of our protocol code is dependent on C++. Absolutely, whatever you feel comfortable to contributing, we're definitely open to it. We definitely accept it. And whether you're strictly comfortable only contributing to that, external crate, but not in the Rust that lives internally within Thunderbird, or only to the Rust's crates, both internal and external, but not in C++, or you would like to contribute but you don't feel comfortable. Like we're happy to essentially kind of bridge the gap in all scenario.
Cool, thank you.
Yeah, no worries. I see in the Zoom chat that Chris asks, aside from the Exchange implementation, what parts of features of Thunderbird make or will make extensive use of Rust? So one feature that already does use Rust is the OS integration for Linux via the Linux system tray, which was written mostly by Heather. It's fully written in Rust, and any extension to it will be also Rust code. Well, in terms of additional features, it will be kind of more of a case-by-case basis. We might introduce some Rust on the crypto side of things, maybe on integrating some of the chat protocols. For example, Matrix has a Rust SDK. Those are just kind of ideas and thoughts. Those discussions on which direction we want to go with what is going to be the next big Rust piece in Thunderbird is still kind of to be determined.
Just as a follow-up, a little bit more specific, would you say that since we have gone down the protocol rabbit hole in Rust for Exchange, do you think that will make supporting other protocols in Rust much easier?
Oh yeah, definitely. There's a lot of code infrastructure that we have written in Rust for Exchange that will be able to just reuse as is for the protocols, whether that's processing or networking or leveraging async. We have for instance, there's the way async works in XP is by using a lot of callbacks. So you call a method to start your asynchronous operation, and then you give it what we call a listener, which is just an object with a bunch of callbacks to it. And for one of those kind of asynchronous interfaces, we have one of those interfaces is something we call a channel, which is essentially what you use to send network requests or maybe to read data from the disk. A lot of essentially most asynchronous operations that return content go through a channel. And we have, for example, some code infrastructure to turn a channel into a Rust feature. So we implement the feature trait we encapsulate a channel into something that implements the feature trait. And so that allows us to use kind of native Rust async await syntax and idioms with async XPCom code, which is an example of something that we will definitely reuse for every other protocol we might implement in Rust, because every protocol will benefit from native async await.
What would you say if you could go back in time and talk to earlier Brendan that was about to embark on the Rust proof of concept, this whole path? What would you tell that Brendan that's about to do this? Is there any word of wisdom you would give yourself? Any there's a gotcha down the road, or
I guess good luck. No, I think there's a lot of things that we didn't know before embarking into Rust, into how XPCom works, kind of the nitty-gritty aspects of it, how the bindings exist, and how we would have to make that Rust code interact with C++. I think those are some learnings that we'll definitely, within the coming months, look into documenting better, and in a way that can be reused, so that we start and we architect future protocols in a way that is more maintainable, essentially. An interesting question from Chris: is there a specific infrastructure to debug Rust code in Thunderbird? What's the typical workflow when your Rust code panics? So answering the second one, which is the easiest, whenever Rust panics, it makes Thunderbird crash, which was a bit awkward because at some point we had a bunch of to-dos the to-do macro for unsupported types of changes when syncing new messages from an Exchange server, which meant that whenever in a normal sync Thunderbird would receive some of those changes, it would just crash, which we ended up changing by just stubbing out those types. So kind of your typical, it does go through all the crash handlers of Thunderbird that we inherit from Firefox, which are fairly handy in terms of crash reporting and so on. But yeah, that's kind of the short answer. It just crashes. In terms of how to debug Rust code in Thunderbird, so you can run Thunderbird through GDB, which is the kind of standard C++ debugger. When you build Thunderbird when you make a debug build of Thunderbird, which I think most developers and contributors would start doing at some point, the Rust symbols are exposed in the same way as C++ is, so you can break Rust code the same way you can break on C++. You can print values and structures the same way you would print in C++. So yeah, it's kind of a handy integration that I don't think we have specific infrastructure to allow that integration. I think it just comes from the existing integration of Rust within GDB, I think.
I think that's been really good, and this might be a natural stopping point.
Yeah, I think so. We're getting to time, so
You've answered a lot of wonderful questions, and
yay.
I think this was really valuable.
Cool. All right. In which case, I'm gonna stop the recording. Yep.